Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Newman projections represent the view along a specific C to C bond. The front atom's substituents are shown on the circle's spokes, and the back atom's substituents are shown behind the circle. Identifying all substituents on front and back carbons gives the full connectivity of the molecule. Moving on to the next step. In projection A, the front carbon bears CH3, H, and CH3, two methyl groups and one H, and the back carbon bears H, H, and CH3, actually an ethyl group shown as CH to CH3, but drawn as CH3 at the bottom. Reconstructing, front C has two methyls and one H, back C has two H's and one ethyl, or the overall chain is C2, C3 bond of 3-methylpentane. The front carbon, C3, has two CH3 groups and one H, the back carbon, C2 or C4, has two H's and one CH3 terminal. This gives a branched 5-carbon chain is equal to 3-methylpentane. Hence, A, T. Moving on to the next step. In projection B, the front carbon has two CH3 groups and wait, re-examining, front carbon has CH3 top and CH3 adjacent with H, H on sides, back carbon has H, 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 3 hydrogens. If front C has CH3 and H, H and back C has CH3 and H, H, this is the C2, C3 bond of N-butane, each carbon has one CH3 and two H's. The projection shows a gauche or anti-conformation of N-butane where each central carbon carries one CH3 and two H's. Hence, B, Q. And for the final step. In projection C, the back carbon is part of a cyclopentane ring, shown explicitly attached to the circle. The front carbon has CH3, top, H, H substituents, plus the ring bond. This is a Newman projection looking along the C1, C2 bond of methylcyclopentane, where C1 carries a CH3 group. Hence, C, R. Projection D shows two Newman circles connected by a bond, representing two C bonds of a cyclohexane ring viewed simultaneously. The substituents visible are 3 CH3 groups distributed at positions 1, 2, and 4 of the cyclohexane ring. This is characteristic of 1, 2, 4 trimethylcyclohexane. Hence, DS. Each Newman projection has a unique carbon count and branching pattern that matches only one name. 3-methylpentane, 6C1 branch, matches only A, N-butane, 4C straight chain, matches only B, methylcyclopentane, cyclopentane plus 1-methyl, matches only C, 1, 2, 4 trimethylcyclohexane, cyclohexane plus 3 methyls, matches only D. Therefore, the correct answer is AP, BQ, CR, DS. The correct answer is shown on screen.